Okay, so now we're on solving quadratics by factoring. Today is the 29th, so let's push that. Alright, so this one was split up into two originally, but I decided to put them together. So I'll be referring to some as like part 1 and part 2 because on the filled out notes there will be a part 1 and part 2. So this first one that we're going to talk about is going to be on the part 1 or day 1 notes. So first things first, let's go over some steps. And then the math version. So remember, the steps is verbally going to tell you what to do, and the math is what it should look like on your equation. So your first step is to set the quadratic equation equal to 0. So normally your quadratic equation, it should already be in standard form. Most likely it says y equals ax squared plus bx plus c. So when you equal it to 0, you're really just making y equals 0 and solving it from there. So let's say, for example, we're given the function y equals x squared plus 3x minus 10. Then doing step number 1 is putting the actual equation on the left side. Alright, so putting the x squared plus 3x minus 10 on the left. On the right, we would just set it equal to 0. And bam, that's step 1. So steps 2 says that you need to factor the left side. Now, if you had put your 0 on the left and had it 0 equals x squared plus 3x minus 10, then you would be factoring your right side. You need to factor the side with the trinomial, or with your equation. So, if you notice, this is a trinomial with a equal to 1. So factoring it, we're going to make our x like we've been doing. 1 times negative 10 is negative 10, which will go on the bottom. And then the positive 3 will go on top. So you want two factors of 10 that multiply to give you negative 10, but add and give you 3. Since the 10 is negative, that means one of them is going to be negative. And the factors of 10 is just 1 and 10 and 2 and 5. So it's actually going to be 2 and 5. And because of the fact that our 3 is positive but our 10 is negative, then one of these has to be negative, and it'll be the 2, because negative 2 times a positive 5 is a negative 10, but negative 2 plus 5 is a positive 3. So then we're going to rewrite this as x minus 2 times x plus 5, but that's still equal to 0. And this is step number 2, is you want to rewrite the equation in its factored form. You could have written x plus 5 on the left and the x minus 2 on the right. You could have switched these two. That's perfectly fine. Either of the two works. So then number 3 says to set each factor equal to 0 and solve each factor for x. So this means that we're going to, and this is going to be actually step number 3. We're going to set 2 equal to 0, and we're going to set x plus 5 equal to 0. And then if you need to, draw a line in between the two so you can see that these are two separate equations. And then solve each factor for x. So on the left side we would add by 2 on both sides, and we would get x equals 2. And on the right side, we would subtract by 5 on both sides. We would get x equals negative 5. Then once you're there, you just have one less step to do. So our last step is to write your answer using curly brackets. So just like we did it in the homework for quadratic roots, where we wrote x equals, open curly brackets, the two x functions, the two x values where the graph crossed the x-axis. This time we're going to write it the same way, except we found ours mathematically this time. So that's y equals curly bracket -5, 2. Now I write it from the smallest factor to the biggest factor, -2, 5. That's why I wrote -5 first too. And then this is your last step. And bam. That would be your answer. Alright, so let's do a couple of examples of that to just kind of see all the different varieties that you're going to get. Because they're not all going to have, like, just like how we did it yesterday. Yesterday we had that not all of our, or not yesterday, but Monday when we did the lesson, we had that not all of our quadratic equations, when you graphed them, their roots weren't always didn't always give you 2. Sometimes they gave you 1, sometimes they gave you none. So on this homework, we're actually going to have all 1 or 2 roots. And so we're going to see a little bit of each one. So doing number, it's a little hot. Doing number 4, from the notes, we have x squared plus 6x minus 27 equals 0. Doing our x, we get -27 on bottom. We get 6 on top. The factors of 27 it's actually a really short list. It's 1 and 27, and then 3 and 9. That's it. So since 27 is negative, that means that you're going to have to take the difference of these, and the only one that's going to be able to give you 6 is 3 and 9. And again, since the 6 is positive, that means the 9 has to be positive and the 3 is negative. So then rewriting this equation in its factored form, we'll write x minus 3 times x plus 9 equals 0. And then set each factor equal to 0. So set x minus 3 equal to 0 and x plus 9 equal to 0. Draw your line if you need to. Subtract by 9 on both sides. And then x equals -9. Add by 3 on both sides. Because remember, you're trying to solve for x. X equals a positive 3. So x equaled a -9 and a positive 3. Bam. Okay, and then looking at number 7. So number 7 says x squared plus 10x plus 25 equals 0. So I didn't mention this over here, but these are actually already equal to 0. If you have your equation on the left equal to 0, then you're good. You don't have to do anything. You can jump straight into step number 2, start by factoring. If it's not equal to 0 on the right side, then you're going to have to move your equation around a little bit to make it equal 0. So again, solving this, 25 and 10. The only factors of 25 are 1 and 25 and 5 and 5. And the only two factors that are going to give you 10 is 5 and 5. So then you would have x plus 5 times x plus 5 equals 0. And then set each factor equal to 0. And solve. So on the right side you subtract by 5 to get x equals -5. And then on the left side you subtract by 5 as well to get x equals -5. Now you could have noticed something at each step. You could have noticed it whenever you wrote it right here, that you have the same factor twice. You could have noticed it when you got down here, when you started doing the subtraction, been like, hey, wait a second, they're the same factor. Or you could have not even noticed it until you got to the end and you noticed that you both gave you -5. If your factors are the same and they both give you the same x value, that means you only have one solution. And that would be -5. So this is the graph, the quadratic equation that approaches the x-axis at x equals -5, and as soon as it touches it, it turns right back around. So it only has one solution. Alright, not all of these are going to be factoring by trinomials. Here's number 12. So number 12 says 8x squared minus 6x equals 0. So notice that you're missing an x, 0. Then you cannot do this by trinomials, because then you'd be looking for the factors of 0, and the factors of 0 are only 0 and 0. 0. That's it. Anything times 0 is 0. Well, actually, the factors of 0 can be anything, because 0 times anything will give you 0. So instead of doing that, we have other methods. We have the greatest common factor method, but we also have the differences of square method. If you notice, though, this can't be a differences of square because you don't have perfect squares on both sides. So we do have subtraction, but we don't have perfect squares. So let's try greatest common factor. They both actually do have a 2 in common, and they both have an x in common. So then factoring out a 2x, you would have 8x squared divided by 2x would give you 4x. And then 6x divided by 2x would give you 3, because the x's cancel and 6 divided by 2 is 3. And then you bring down the subtraction, but this is still equal to 0. Alright, well then you still have to set each factor equal to 0. So 2x equals 0, and then 4x minus 3 equals 0. And anything, like, these two were multiplied against each other, so they were both factors. Anything multiplied against each other, once you factored it like this, those are factors. So starting with the 2x equals 0, you would divide by 2 on both sides. And you would actually end up with just x equals 0, because anything divided by 0 is 0. 0 divided by anything is 0. Then adding by 3 on both sides, on the right side, you would get 4x equals 3, and then divide by 4 to get x equals 3/4. So then your factors on this one were actually x equals 0 and 3/4, which shows you that yes, it is totally possible to get a fraction as one of your zeros, and it's possible to get a 0 as one of your zeros too. So don't get scared if you see those. Like, fractions and zeros, they're friendly. They're not gonna bite you in the hand. They're not gonna, like, shove you off the boat. They're not gonna shove you off the airplane with no safety jacket. Like, I got you. I'll be your safety jacket, guys. You got this. Alright. And then there's just 2 more I want to talk about for this one, and then we'll talk about the part 2 of the notes. So number 15 is 4x squared minus 81, which equals 0. So this one, it is again a binomial. It's subtraction. You don't have a c value, so like the possibilities are endless. But if you notice, 4 and 81 are perfect squares, and x to the square, x to the second power, you can't take the square root of it. So then, taking the square root of 4x squared, you actually get 2x. And then taking the square root of 81, you get 9. So remember, this is the factor of, since 4x squared is on the left side, you're still going to have 2 sets of parentheses, and they're still equal to 0. Since 4x squared was on the left side, that means 2x is also going to be on the left side. Since 81 was on the right side, that means 9 is going to be on the right side. Remember, it's a squared minus b squared equals a minus b times a plus b. So one of them has to be minus and one of them has to be plus. It can be either or. Okay, and then setting each factor equal to 0. 2x plus 9 equals 0, 2x minus 9 equals 0. Alright, solving the left one first, you'd add by 9, and then you'd get 2x equals 9, and then divide by 2 to get 2x equals 9 halves. And then the right one, it's going to be solved similarly, except instead of adding by 9, we're going to subtract by 9, because we have a positive 9 in our factor. And then you get 2x equals a negative 9, and then divide by 2, x equals a negative 9 halves. So when you're doing the differences of squares method and you're taking the square root of things, you're actually going to end up getting the same factor, but one positive and one negative. So you would write that as x equals negative 9 halves, comma 9 halves. Alright, and then number 17. X squared plus 4x equals 21. So the first thing to note about this one is that it is actually not already equal to 0. like the other ones were. This one is equal to 21. So you have to get it to be in the correct position for this to work. So to get your quadratic to be on one side and 0 on the other, all you have to do on this one is subtract by 21, subtract by 21 on both sides. And then since the left one has an x squared and an x, but no constant already, then you won't be combining any terms, but you'll just be tacking it onto the end. So it'll be x squared plus 4x minus 21 equals 0. And then you're ready to start. So 1 times negative 21 is negative 21 and 4. So 21 only has 2 sets of factors, 1 and 21 and 7 and 3. But again, since our 4 is positive, then our 3 has to be negative and our 7 has to be positive, because negative 3 plus 7 is a positive 4. And then rewriting this, we would get x minus 3 times x plus 7 equals 0. Setting each factor equal to 0, x minus 3 equals 0, x plus 7 equals 0. So adding by 3 on the left side gets you x equals 3. Subtracting by 7 gets you x equals negative 7. So then x is going to equal this negative 7 comma 3. And if you were to actually go ahead and graph this on your graphing calculator, you would actually see that this equation, this quadratic equation, is going to cross the x-axis at negative 7 and 3. Alright. Okay, and then this is actually going to be the day 2 notes. I did write day, not part on them. So, alright, there's 2 different kinds on this one. So we're only going to do 2 examples for this. Well, 3 examples for this. Okay. So number 1 on this one, because remember this is a whole other set of notes, so this one actually starts at 1 again. It's 2x squared plus 10x minus 8 equals 0. So this one's already equal to 0. I want you to note though that your a, b, and c are all even numbers. And all even numbers have 2 in common. So remember to always, like, if you have a trinomial and you can factor something out at the beginning, your greatest common factor at the beginning, before you try to factor and solve it, it makes it so much easier. So doing 2, factoring out a 2, 2x squared divided by 2 would just give you x squared, 10x divided by 2 would give you 5x, and then 8 divided by 2 would give you 4. Oh, I went outside and so my allergies are getting me. Alright, factoring the inside, we have negative 4 on the bottom and 5 on top. So the factors of 4, actually I don't know why I wrote negative, this is a positive the whole entire time. I was looking at this like, there's no factors of 4 that'll give you positive 5. If your 4 is negative, okay. The factors of 4 are 1 and 4 and 2 and 2. 2 plus 2 is going to give you 4, but 4 plus 1 is going to give you 5. So using those, and then rewriting this, you get x plus 1 times x plus 4 equals 0, and you still have that 2 up there. Then you're going to set each factor equal to 0. So the 2 is going to be set equal to 0, x plus 1 will be set equal to 0, and then x plus 4 will be set equal to 0. But 2 never equals 0, so that one's kind of just discarded because that's never going to be true. So then you move to the next one. X plus 1 equals 0. So negative 1 minus 1 minus 1. So you get x equals negative 1. And then you do minus 4 minus 4. And you get x equals negative 4. So then you're set, and the answer and the end would be x equals negative 4 comma negative 1. Alright, this is actually example number 8. It's 4x squared plus 12x plus 9 equals 0. Okay. If you notice, we have two evens and an odd number, so there's not going to be a greatest common factor in there. Especially since the only factors of 9 is 1 and 9 and 3 and 3, and neither one goes into everything, but when you want to do this and make it like the other one, you want it to be a number bigger than 1, so starting with 2. So instead, we'll start factoring this. Previously, we always had 1 at the front, so 1 times 4 would be 4, but now we have 4, so you got to do 4 times 9, gives you 36, and then you'd place 12 at the top. And then the factors of 36, even numbers have more factors than odds. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Alright, so you need, since we're all in addition, then you need to, when you combine these two factors, you're going to get 12. And the only one that's going to give you that is going to be the 6 and 6. So placing each 6. Alright, and then you have to draw a box. You're not done here. There's more to do. You would do the top left corner, would you put your first number, 4x squared, in the bottom right corner you'd put the 9. And in the two diagonal corners, you would put your two factors, so 6x and 6x. And remember, these two always have x in them. So looking at the left column, 4x squared and 6x, their greatest common factor is actually 2x. And then 6x and 9, their greatest common factor is 3. 4x squared and 6x, their greatest common factor is 2x. And then 6x and 9, their greatest common factor is 3. So rewriting this trinomial, you get 2x plus 3 times 2x plus 3 equals 0. If you have a number greater than 1 in front of your x squared, your leading coefficient is greater than 1. You cannot stop just by finding these numbers. You have to keep going and factor these out. Because had you stopped here, then you would have had 4x squared times 4x squared, which is 16x squared, which is way more x squared than you even started with. Once you find your factors, if you are unsure, go ahead and distribute it. 2x squared times 2x squared will give you 4x squared. 3 times 2x will give you 6x, plus 3 times 2x will give you 6x, so that will give you 12x, and 3 times 3 gives you 9. This is the correct factored form. So if you notice, it's the exact same number, the same factor, 2x plus 3 and 2x plus 3, and the last thing that happened when we had the same factors, we got the same exact x. So you could honestly just factor one of these and set only one equal to 0, and then you just do minus 3 minus 3. So you get 2x equals negative 3, and then divide by 2. And you get x equals negative 3 halves. And that would be your answer. X equals negative 3 halves. And bam, all done. One down. Alright, and then the last one I want to talk about, it's number 9. So number 9 has 3x squared plus 7x equals negative 2. Again, your first step before you can even start any of this is make sure it's equal to 0. If it is not equal to 0, then move your factors around to get them equal to 0. In this case, you would add by 2 on both sides. To get 3x squared plus 7x plus 2 equals 0. And 2, 7, and 3, they're all prime numbers. So go ahead, still go with your x. 2 times 3 is 6 and 7. The only factors of 6 are 1 and 6 and 2 and 3. 2 and 3 will give you 5, but 1 and 6 will actually give you 7. So then drawing your box, place 3x squared in the top left, and then place positive 2 in the right bottom right, and then place 1x and 6x somewhere. I'm going to place the 6x over here and then the 1x over here. You could have placed the 1x over here and the 6x over here. It's going to give you the same exact factors. It might just give you the factor I'm about to get sideways on top and the factor I'm about to get on top on the side, but in the end they're going to be the same. Alright, 3x squared and 6x. The only thing they have in common is 3x. X and 2, the only thing they have in common is a positive 1. And that's possible, guys. Remember, some of these might only have 1 in common. 3x squared and x will have an x. That's the greatest common factor. And 6x and 2 will have a 2. So then this will leave you with the factored form of 3x plus 1 times x plus 2. And remember, that's still equal to 0. Set each factor equal to 0. 3x plus 1 equals 0. X plus 2 equals 0. Alright, so then start by subtracting by 2 on both sides. So you get x equals negative 2. And then subtract by 1 on both sides to get 3x equals negative 1. And divide by 3 to get x equals negative 1/3. And remember, fractions are totally fine. They're your friends. They're not your enemies. They're not going to eat you up whole. No. So then these would be negative 2 comma negative 1/3. And bam, that's it. You are not going to get any that say no solution. You might get one that only has one solution. You might get some that get 2 solutions. You know what? You might get quite a bit that are fractions. You might get quite a bit that are just whole numbers. Everything's going to depend on what kind of problem it was at the beginning. If you need anything, please let me know. Do not wait until after it was due and turn in a paper and be like, Ms. D, I don't know what I was doing, like question marks all over it, when you had a whole week to do it. And you could just send me an email and say, Ms. D, I don't know what I'm doing, and I'll be like, alright, hop on Zoom right now, I'll teach you.